All right, are we on? Can folks hear me? Let me know. Let's see. Make sure we're on. Anyone can let me know if they can hear me okay. Oh, good. People can see me and hear me okay? Thanks. Sorry, there was a weird little startup there, so I wasn't sure if we had started or not. Great. Well, thanks again, folks, for jumping on here. It is about quarter to 11 a.m. here Mountain Standard Time. That would put it around 5:45 p.m. in Iceland. If you're here, you kind of know what's going on a little bit. We've had some earthquake activity north of Grindavik in Iceland. And so we're monitoring that. It appears that an eruption is definitely possible, but not certain at this point. And I just got in the office not that long ago, so I'm going to learn with you here. We'll do this on the fly. Amanda Joe was good enough to notify me of some things taking place, get a hold of me. I was actually out at breakfast with my wife and two friends, but we had a little chat there. And then I hustled home, grabbed a few things, and came to the office. So thanks again for joining me. We do have Amanda Joe, and I believe Susan, and I believe Lisa moderating our live chat. And we'll, of course, take care of some questions there. But want to do a big shout out to them for providing our moderation today. So just as a quick update, we're looking at the live cam shots here provided by Live from Iceland. Nothing on the cameras as of yet, but the biggest issue today and the reason for the alert level being raised is this seismic activity just northeast of Grindavik. And so they have evacuated the town, I've heard from Amanda Joe. They have evacuated the Blue Lagoon. So the good news here is if anything happens, we've got people out of harm's way. They've even evacuated some of the media, some of the people who are trying to do drone flights and other things. They've moved them back to a safer area. As you can see from the seismic data, the clustering of quakes seems to be most concentrated between Hagafelt, the hill just to the northeast of Grindavik, and proceeding up to the northeast to about Stora Stogafelt. The biggest quake in this series looks like is a 2.4 with a depth of 4 kilometers. And we can kind of scan around a few of these quakes, smaller ones here. But in looking at the quakes, one thing I noticed was I haven't seen a progression. And I've been looking at this for about an hour or so. But for the most part, we haven't seen a progression of these quakes upwards. So it appears, my best interpretation so far, just cutting to the chase, is that magma is intruding into this zone. It's breaking rock. It may be widening fractures and cracks a little bit, or it may be moving into new pathways or fractures that it had not occupied previously. But there's nothing right now to suggest that the magma is on its way up to the surface to feed an eruption. That may change very quickly, but right now we have magma moving in the subsurface into this region where we haven't seen any earthquakes for the most part over the last few days. So there's definitely magma migration in the subsurface, but nothing that suggests we have it moving up to the surface. I'll handle some questions here from you folks in a bit, so the moderators will let you know how they'd like to receive those questions over there in the live chat. We also have the Nightbot there who reminds us of several things. So there's the Nightbot with some information on how you can submit your questions. Amanda Joe's also working with our good friend Geologist, who has the Just Icelandic YouTube channel, and she's sending me information. So he was down there, and this is an update from him. He was able to see an area where there was steaming in an area that wasn't really showing much before. He's putting one last drone up and will let me know if anything interesting is coming through and where he's looking. The steam thing with these earthquakes being as deep as they are, my take on that is that, we've had people, I've seen people on the Live from Iceland chat also seeing little wisps or plumes of water vapor here and there. I don't expect to see any gases, volcanic gases coming out until the magma is much closer to the surface and until we have earthquakes that look like they're a lot shallower. Right now, it just doesn't look like the magma's close enough to be changing anything at the surface. Based again on what I'm seeing from just the webcams and the earthquake data from thousands of miles away here in Idaho. So take that as you will. Um, it it's we have these lava fields that are still hot and cooling and degassing. We have the sun going down and the temperatures maybe getting colder. We have a geothermal system. We have hot groundwater beneath this area because the power plant's there in the Blue Lagoon. And all those may also be factors that might lead into people seeing steam coming out of the ground and whatnot. Steam coming out of the ground or water vapor is very different than volcanic gases and can come from very different causes, I suppose. So let's go back to the earthquake data. Just let me spend a few minutes here just updating you and also processing this myself. We're kind of doing this in real time. So just if you'll allow me to just think out loud a little bit, let you know what I'm seeing, and then we'll turn over to the live chat and see what questions you guys have. Yeah, I appreciate Jeff Stever. Thank you for your donation. I am excited that this happened during the day. The last several eruptions were at night or the middle of the morning, 3 o'clock in the morning, and so it's nice that it's not just during the daytime, but it's also on a Saturday. Had this taken place on a school day with me teaching classes, my response time would have been a lot lower. So this is pretty optimal here. And I did see people earlier today. There was a few folks that had noticed this small cluster of very small quakes near Lake Klevervatten to the east. Again, these do not by any means indicate magma is over in that area. I think this is probably, again, just tectonic stresses. These quakes are all very low magnitude, and I wouldn't even call that really a swarm. That's maybe just a dozen or so. But if we come back over here, we might be able to play with some of the data here and see some different changes that took place. So one thing we can do is play with the depth. So if we allow for all earthquakes 8 kilometers and deeper, and let's say if you just for kicks, let's just stretch that down to 10 kilometers. That's about 6 miles if you don't speak metric. And that's the last 24 hours. If you've been watching my updates, especially, I did one just yesterday on Friday, we had essentially very few earthquakes here. I think it was 1 or 2 at best. And so there's definitely been a big uptick in seismic activity. This does show not just the space or spatial concentration, but also the temporal time concentration, that this would definitely qualify as a true seismic swarm. But watch when we select out. So there's our 10 kilometers worth of earthquakes. And then let's take that up to 5. Okay, so that weeds out a few. And now as we now let's just take it up to 4. Okay, that gets rid of a few. And then let's take the maximum depth to 3. And then let's go up to 2 just for fun. So you can see there's a few there, but just not a lot. And so the magma is definitely moving. It probably is moving a bit towards the surface, but where this actually goes is anyone's guess. So a couple possibilities. How will this play out? What are the scenarios? We could see continued earthquakes, continued seismic activity for the rest of the day and into tomorrow, into Sunday. This does not have to culminate in an eruption. This could be magma moving into some new fractures or pathways that it did not occupy previously. And if we have a limited volume or pressure in that magma chamber, then this could be an intrusion event like we saw on November 10th. I think given what we see in the last 3 times, this is most likely to become an eruption. But until I start seeing some shallower quakes there, it's hard to say for sure. So the quakes might be a good thing to keep an eye on and track. And obviously looking at the webcam. If we were to see an eruption on one of the webcams, what would we see first? What we would probably see, based on my experience, is as that fracture becomes a pathway for magma, and the magma's, within 100 meters or less of the surface, the gases are going to tend to come out first. So depending on the view, it's a clear day, so it could be a little tricky, and we are heading into dusk. So once this is nighttime and these cameras are dark, the first indicator will be the actual eruption of the lava at the surface. But if it happens during the day and we have the right webcam looking in the right area, and from the right distance, like this upper right camera, depending on how big the eruption might be initially, it's hard to say if we'll actually see something. But the gases coming out of those fractures first would be the most likely first indicator, and that would be followed within a few tens of seconds or so, most likely, by lava being pushed up into the air, actually being thrown out of the air, what we call fire fountaining, as that very gas-rich, gas-propelled lava erupts airborne, falls back down to the ground, and then that'll start to feed the lava flows, which will start to pour away from the vent and head downhill. So that's what you're looking for. If you're watching the webcams and wondering, what am I looking for here? Because you're not going to see the earthquakes. That's the seismic data. But what you might see is gases coming out. The gases, those sulfuric gases, will look a little, they won't be very white. They'll be more of a light gray kind of murky color. They won't be brown. And that would be the first indicator. But most likely, we might catch that optically. But most likely we'll definitely see the eruption once the lava is being thrown out of the ground. And the folks at Live from Iceland, they can then switch to the right camera, zoom in, and give us a nice view of what's taking place there. So back to the seismic data. So here's 10 kilometers depth, and I kind of just showed you as you get down to these shallower depths, we're just not seeing a lot of earthquakes there, just very few on the feed there. The other thing I want to play with here, let's just send that back down to like 10 kilometers, is looking a little bit at the timing. So if we look at the last 12 hours or so, we can see that the quakes were there about 12 hours ago. I'm just trying to get the timing down a little bit. 18 hours. Oh, yeah, I'm going the wrong way with this. Let's go down to 6 hours. Okay, so they were within the last 6 hours, within the last 4 hours. Yeah, so about 3 or so hours ago, I would guess. Someone probably has a good record of exactly when these things really kicked up in earnest. And I suppose it's over here in terms of the time component when a lot of these quakes came in. And then if we look at the last hour or so, we can see, and this is sometimes helpful too, as you just look at the last cluster over the last time. So just north of Hagafelt over the last 2 hours, we seem to have quakes 1.8, 1.7. Again, the depths around the 5 to 6 kilometer range. 1.8. There's a bigger one up here that's 2.6, but a little bit deeper quakes, right? And then if we just look at maybe the last 30 minutes or so, yeah, not much happening. Last half hour, there's a small one, a little bit shallower depth. Interesting. Here's one that just maybe popped up. There's 2.6. And 15 minutes ago, and then maybe going back to an hour ago. Yeah, that same kind of pattern there. Interesting. So that's what we have on the earthquakes. Let's check out the Met Office. They just put out an update within the last few hours as well. And I haven't read this, so we'll just do this together if you don't mind. Intense. And I'd left the Icelandic one up. I don't know. Let's see if they have the English one up yet or not. I don't know if that's as updated. No, this is the older one. Oh no, this is updated, so we can use this one. Magma movements detected, increased likelihood of a fissure eruption. Updated today, 5:30 UTC, so that would have been just within the last hour or so. An intense swarm of microseismic activity is occurring east of Slingerfeld. The seismicity indicates magma movements have begun and that a fissure eruption is likely. I would agree. Seismicity began at the southern end of the fissure that formed on December 18th. Yeah, so I didn't mention that, but where we're seeing this happen is more or less between the December or February, they overlapped a little bit. Um, so here's the January. Let me get this all straightened out for you. January lava field here, and then up here in the orange and red is the December and February lava fields. And it looks like this area here that's where the earthquake clusters are happening. So if I had to pick a vent location right now, I would probably pick this little zone right in here. But it is possible that it's further to the north on the system, and it's also possible for it to be further south. But somewhere between Hagafelt and Seilingarfelt seems to be the most likely scenario right now. Going on with the Met update, and then they have an update at 5:30 UTC that the seismic activity moves southward toward Hagafelt. Real-time GPS measurements show less signs of deformation than before previous eruptions. This could signify that less magma is on the move than before. So they have some indication that there's maybe less magma moving through the system than with some of the previous eruptions. At present, the depth of the seismicity does not indicate that magma is propagating to the surface. I agree. That's what we just talked about. The seismicity is too deep to show that magma is working its way to the surface and feeding an eruption, but that could definitely take place. As of 5:30 UTC, likely scenarios, the magma intrusion will not necessarily lead to a volcanic eruption. However, while the situation remains uncertain, an imminent fissure eruption cannot be ruled out. So that's where this could go, team. Even though you'd think on the surface that the indications are that we should be seeing an eruption, there's no guarantees. Lots of magma migration movements don't end in an eruption. They just sort of, magma has moved into some other area, it stalls, it doesn't have the pressure in terms of gases to actually propagate to the surface. I haven't looked at the GPS data at all yet, so we'll just look at this together. So there's our trend there over the last, each dot is an 8-hour data feed. So the last one is a little bit of an uptick there, but nothing remarkable there. If we switch over to the Blue Lagoon data one, this one interestingly shows, and we've seen this trend before, so you can see the latest inflation movement of this GPS station, and then the last couple days the trend slows down a little bit. I wouldn't say it's stalled, but it definitely slows, and that's a bit similar to what we saw in the run-up to the February 8th eruption. A little bit of a lag here in terms of the slope of these data points. Interesting. Maybe look over at Elverp. And yeah, similar thing here. I think I'm seeing a similar trend here with, let's get that over. There we go. So here's the lead up to the February 8th eruption, upward trend, inflation. There's some spots in here where the data stagnated for, maybe a day or two, but then it picks back up. And then in the days, 3 or 4 days preceding that eruption, you can see the data definitely stagnating there in terms of uplift. The uplift rate was not there. In fact, essentially the GPS station was not moving much, if at all. And similarly here, we might be seeing a little bit of that here, although there's a little bit of an uptick there. Bigger error bars at this station. It's further away off to the west. So interesting. Okay, let's see maybe one more thing there, and then we can come to some questions. I don't have a lot prepared for you because I just came in on the fly. And I think what I'd like to do is, obviously we might see something take place as the sun starts to set. We're kind of going into golden hour there on the Reykjanes. And we'll keep this specific live stream going for a while until we feel like we've answered some questions. You guys feel like we've got some good things covered. But if it looks like we're not headed towards an eruption and the data is not showing it progressing that way, this live stream will end at some point, in an hour or so, whatever. And then if things pick back up, I'll jump back on, whether that's, later today, afternoon my time, or it might be tomorrow. It just depends on how these things go. One quick programming note, I am scheduled to have a interview tomorrow, Sunday the 3rd at 5 p.m. Iceland time or 10 a.m. Mountain Standard Time with Nick Zentner. He's been very gracious, and he said, hey, if there's stuff going on in Iceland and you need to do that, then please go ahead and make that your focus. And so there is a chance we may postpone our interview with Nick to next Sunday. He's very gracious and flexible with his schedule and letting us do that. So we may do that, especially if it looks like the eruption might take a while, and if it's worth continuing to monitor this tomorrow. There's a good chance this progresses quickly, that magma could quickly propagate those 5 kilometers to the surface, maybe within an hour or less, and we could see an eruption here in short order. That eruption might not last very long. There's good data to suggest that the eruption might not last that long in terms of time. That's what we've seen with the last 3 eruptions as well. So we'll just play it by ear, but just look for that possible programming change that we may bump our conversation with Nick, which I want to be able to focus on and spend time with. We may do that next Sunday instead. So I hope you're okay with that. So let's see, did we finish with the GPS data? Maybe someone will alert me to any sort of trends I'm not seeing here. But yeah, the GPS data at this point, the GPS data helps us track magma movement and estimate magma supply and volume between eruptive events. It's not always super critical data, immediately preceding it. So the seismic data is probably our best friend there. So, okay, looks like Amanda Joe's already sent me the first batch of questions. So let me pull those up here and we'll go through some questions. Thanks again for joining me here today. I hope you're well. Okay, so where'd those go? Oh, and someone asked about my shirt. No, this is not an Arizona State University shirt. This is the Trail Alliance of Southern Utah. So this is a group that builds mountain biking trails in southwestern Utah. So just supporting their cause. Thank you to all who have donated and helped out the channel. Much appreciated. Yeah, it takes things like that to keep this thing going, and super appreciated. Thanks. All right, the first batch of questions from Amanda, and I'll do my best with these here, team. So let's just pull these over. And maybe I'll show the questions and then we can go back to the live cam view a bit here too as well. Okay, so oh, here's like is this a report? This is not a question. So there's so this is what we talked about earlier. Yeah, one of the stations in Iceland was reporting as of 3 or so minutes ago, little indication magma is emerging. We saw this in the Met Office update. Seismic activity moved a little bit to the south, but the small earthquake activity has decreased. Okay, so that's interesting. The deformation was smaller than experts have seen before. Seismic activity is mild. So it seems the magma is moving less. There's little indication that the magma is coming to the surface now. In the run-up to the eruption, the seismic activity has not decreased as is happening now. Maybe it's just a magma run and nothing will happen. Most likely scenarios that there is no eruption. So that may be what the data is showing now. I admit that an hour or so ago when Amanda Joe first got a hold of me, I saw all the data and all the earthquakes and thought for sure that we were going to have something. But given that we're not seeing those quakes shallowing upwards over time and a few other things, that may be a good indicator that we're not seeing that an eruption may not be the most likely endpoint for this. From Dirk Kruger, what are the chances of an eruption in the sea as magma moves south? And I guess some of these blue questions were from multiple users, so other people may have asked that as well. I don't think that's likely given where the earthquakes are. So if we come back to this here, and let's just throw the whole enchilada package in there. Yeah, if we're going to have earthquakes in the offshore region, we would expect to see earthquakes propagating to the southwest, right through town, and into these offshore regions. And we're just not seeing that there. Any of these one given dots on this map here is just a stress release type of thing and not indicative of magma moving into that area. So if you look at this one over here, or here's one offshore, those aren't alarming. What we'd expect to see is a swarm and trend of earthquakes in this region out here, and that would be an indication that a submarine below ocean eruption is possible, but we're just not seeing that right now with the data that we have. So chances of an eruption in the sea, well, he says as magma moves south. So if the magma does move south, but that the earthquake should track that, then there would be a chance of an eruption. But right now, with the data as constituted, we're just not seeing that. Seshu, within the swarm of quakes, there was also a 2.7 at LD Island, though I don't think that has to do something with it, but it happened same time as the swarm. Yeah, so remember that these tectonic systems, yeah, so it might have been one of these quakes out here, or maybe we need to pull the time range down a little bit and see if there was a bigger one. Yeah, so it might have been a little bit earlier than this 24-hour period. Even though it's the same plate boundary, these things are segmented, and so the faults and the earthquakes that happen on any given segment aren't necessarily related in terms of releasing the stress altogether. Now, what can happen, and this is probably what we saw over here to some degree, is you can have one area that's active seismically generates regional stress that causes quakes in other locations. So these quakes occurred at this time, possibly because the tectonic stresses that were being transmitted from these earthquakes caused the quakes in this region to happen sooner than they might have otherwise. But you know, a big earthquake down here doesn't necessarily mean you're going to get an earthquake here. You know, and this goes not just on the Reykjanes, but throughout Iceland. Also, as we look at volcanic systems, so there's nothing related there. So these quakes way over here in central Iceland are interesting, but are not related to what's happening in the Reykjanes. And maybe there's that bigger quake down there. Yeah, there's your 2.7, so it's a little further to the south. It's about 100 kilometers southwest of LD. So it happened today. It was a shallower quake, interesting, but it looks like it's a one-off, right? You don't see any other quakes in that area. The pattern is totally different than what we're seeing here, where we have good indication that it's magma movement and migration. So whenever you see like a one-off quake like that, that's definitely a tectonic quake. That's faulting versus what we're seeing here, which is mostly driven by magma migration in the subsurface. Okay, let's see. Next question. Hopefully I'm doing okay with these questions. Connie's Little Corner, is there a domino type effect when tectonic or volcanic shifts occur? How far away does it cause push on the plates? So there's research done on, and it's a bit of a, I'm not up to date on the latest research, but I know there's been some studies that have looked at something called seismic triggering, with the idea being that if you have an earthquake in one place and that changes the stress conditions or the stress regime in a region, is it possible that that earthquake occurring maybe triggers an earthquake on another system or even further away? And there is some evidence to suggest that does take place. So basically, if you have an area that's under stress, it's going to have an earthquake at some point, but we're just waiting for the rocks to fail and that critical stress level to be reached to generate the earthquake. So if we're right at the cusp, right? I mean, it's literally waiting for the straw that broke the camel's back, if you will. And if you have an earthquake in another area that transmits stress or redistributes the stress such that now it's greater and that earthquake occurs, so you would see that relationship, right? But just because something correlates doesn't mean that it's something that causes it. So we have a little fun phrase in science we sometimes use: correlation does not equal causation. Just because something coincides or correlates in time or in space doesn't mean that it directly causes it. Now, that being said, like I said, there's been some studies that suggest, but not conclusively as far as I know, that earthquakes and stress conditions can sort of quote unquote talk to each other, and that there can be some minor amounts of triggering. And that may be, you know, what's happening over here at Lake Klevravatten is that the stress by this magma moving through these rocks, that stress was transmitted to the east and in all directions really, but on these fault systems, which are already fractured and building up stress that may have caused some of these quakes to occur here. So hopefully that was a good or a decent attempt to answer your question. Gilfie is asking about Klevervatten quakes and significance. Yeah, so I kind of mentioned that a little bit here. I don't see any evidence here. This is a cluster. Maybe there's enough there to constitute a swarm, depending on how you slice it. But it's very likely that what you have here, and we'd have to look at the time relationships a little bit here. No, some of these came in before. So, sometimes when I just see that at face value, one possibility is you have a main seismic event, so this 2.4, and then the question would be, well, are these other quakes coming in after as aftershocks, right? You've changed the stress conditions, and now there's some adjustments to that new stress regime caused by that faulting event, by this shift. But it actually looks like this one took place at almost 3 in the afternoon, and a lot of these quakes actually preceded it in terms of time, which is interesting. Which could mean that they were foreshocks. I mean, you could have small earthquakes that redistribute stress, and then a bigger one comes later. So, but I don't see anything here that would seem to suggest that it's magmatic intrusion. This is a tectonic plate boundary, and so the primary stress that creates most of the earthquakes in Iceland is tectonism and plate tectonics and faulting. So I always default to that being the dominant cause of earthquakes in Iceland, unless you're seeing, as we are here north of Grindavik, also seeing clear GPS and ground deformation signals indicating inflation. We had, in this case, known volcanic activity in the area. We have all the indicators that magma is in the subsurface. And so here we have to sort of delineate between magmatic and tectonic quakes. But when I come over here, even though it seems to be pretty close spatially, it's maybe, 15, 20 kilometers away. And some of you might think, well, that's close enough. I just don't see that those are magmatic at this point at all. And so I'd expect to see other trends, other data signals that suggest that they're related to magma supply. So hopefully that satisfies or helps a little bit clarify, not just Gilfi who asked that question, and thank you, sir, or anyone else who might be wondering. Bjorn de Baker, what in geology is deep and shallow? Oh, good question, I guess, when we're talking about earthquakes. It is somewhat relative to whatever you're considering. In general, we consider shallow earthquakes to be down to about 20 kilometers. That's maybe 15 miles, something like that, would be a shallow quake. If I'm specifically referring to what's happening in the Reykjanes, I think of like 8 to 10 kilometers as a shallower quake because of this type of system. Deeper quakes at subduction zones where one plate's diving beneath another, like you see in Indonesia, Japan, off the coast of Alaska, in the Aleutians. Deeper quakes there can reach hundreds of kilometers. And maybe just as a fun little exercise, since we're just sort of in learning mode right now, while we're kind of waiting to see what happens in Iceland, let's take a look at that real quick. So let's look at, here's our global earthquakes for the day. This is just the USGS feed, just the one I'm most comfortable with. I'm sure there's other nations that have a similar seismic network. And let's look at the last 7 days of earthquakes. Let's look at something a little bigger. So 2.5 and above over the last 7.5 days. And as I scroll through these quakes here, so for example, we had this 4.4 in Chile. And this earthquake was, I lost it. There it is. 167 kilometers deep. If you look down here at the bottom left corner. So that is definitely that's a deeper earthquake. That's a subduction zone related earthquake. All plate boundaries, whether they're divergent, convergent, meaning they're or subduction zone, or transform, strike slip, they all produce shallow earthquakes, unfortunately for humans, because shallow earthquakes transmit stress quickly and with a lot of the amplitude of the shaking right to the surface. So unfortunately for humans who live at the surface, all plate boundaries produce shallow earthquakes. The only settings that produce very deep earthquakes, where you're going to see something like that that's over 100 kilometers, is going to be at the subduction zones, where one plate's diving beneath the other. So that's why it's always important as you're looking at earthquakes. Just because you see an earthquake that might look large, right? Like maybe, here's a 5.0 in Alaska, or here's some, this was a China one. I thought they had maybe it's too long ago. It was a 7 over here a few weeks ago. Anyway, well, we could pull that up. We can just pull up there we go. It should be in there. Is it this one? No. Maybe it's hiding under there. Anyway, my point is that you can, whenever I see a bigger quake that could be destructive to people, I always look to see what the depth is, because if it's a deep earthquake, that seismic energy is not getting to the surface as quickly, and therefore there's a good chance that it's not a very destructive earthquake, that it potentially was not a hugely significant earthquake. There's like a 6.3. Again, divergent plate boundary. Look at the depth, 2 kilometers. Here's one, San Andreas Fault, 18 kilometers, shallow quake. If we pull up, let's pull up. Yeah, so I don't want to take this too long, but I think you get the idea, right? So here's divergent plate boundary. Typically, these intraplate quakes, like this one in Africa, like nowhere near a plate boundary, those tend to be shallow as well, 10 kilometers. I know we've had a few in Texas over the last few weeks out here in West Texas. These are also 8.3 kilometers. These are also pretty shallow as well. So I think I got a little sidetracked from the question, but I hope I gave you some ideas there about deep versus shallow. I would say in general, 20 kilometers to the surface is shallow. And then you could, 20 to 60 kilometers, we might call intermediate depth. And then anything below 100 kilometers, let's call that deep, a deep earthquake. From Shatra, how shallow would the earthquakes need to be to indicate the magma was likely moving upwards? I would want to see quakes out here. Let's go back to our feed of data here. No, that's not right. Wrong window. There we go. I would want to see quakes in that 3 to 2 kilometer range. That might be a good number to see that things are progressing upwards. So if we look at the last 2 hours and just kind of look at these in terms of depth, 5, almost 6, 4.5, 5. We come out to these ones over here, 3.7. 5. So you can kind of see a theme here, right? So just looking at the depth of the quakes. And this is what's kind of fun. You guys can be, become scientists. 3.3, just looking at the data there. So anyway, so did I answer that question? Oops, wrong. There we go. Yeah, so how shallow would they need to be to indicate magma was likely moving upwards? I'd like to see some 3s and 2s clustered both spatially and temporally in terms of time, and then I would feel much better about interpreting that data as upward magma migration. John from New York, do you think the magma is moving north of the previous eruption because the weight of the lava previously ejected? Possible. I mean, it is a factor, but I think it's pretty small. So the idea here is that we have placed on top of the ground, we have placed lava, right? January 14th, December 18th here in orange, and in red, February 8th. So we've transferred some of that molten dense magma. We brought it to the surface because of pressure and gases. As it reached the surface, most of the gases escaped, and some of the gases are still escaping as it's degassing. But we've added some dense, heavy rock across the landscape. And I think in a previous update, weeks or maybe a month or so ago, I actually calculated for you estimated the weight of the lava at the surface. We calculate a average bulk density of the lava, how much area it's covering, and then we can figure out the actual weight of the lava. And so I don't think it's playing much of a role right now. The magma is still 5 kilometers down. Whether or not you have 5 to 10 meters of lava over one area versus another area that doesn't have that extra little bit of chocolate frosting on the cake, I don't think it matters a whole lot. Is it a variable and a factor? Probably, but I think it's pretty insignificant would be my guess. And I guess we see that here, right? The February eruption largely overlaps the December eruption. So it didn't, otherwise you'd expect the lava to be erupting from some new area and not reoccupying that same area. So I don't think it's a huge factor. Benjamin Papandrea, if there's an intrusion without an eruption, then the cycle starts again. Wouldn't that older magma currently intruded get erupted by the next intrusion? Yeah, so then the idea would be if this event taking place today is magma intrusion into some new area, we're putting the magma into some new place that it didn't occupy previously. That's why we're seeing the earthquakes. So if we do that without an eruption, it would be interesting because you can get several of these magma intrusion events. You can get dozens of them possibly, and none result in eruption. As long as the magma is pressurized, it seems to have filled up as much space as it can underneath the Svartsengi area where the magma reservoir is. So now it's trying to get out and occupy new spaces. It's trying to find it's more magma's coming up from depth, and it's got to put that magma somewhere. And if it can keep finding places in the subsurface to place it, then it will, because that's the easier solution, right? If there's a big hollowed out, if there was a huge, I don't know, lava tube in the subsurface that the magma could occupy, it's more likely to fill in something at depth in the subsurface than it is to break, fracture rock, move up against gravity, and make its way to the surface. And so that older magma could get erupted by the next one. And sometimes we see that when we look at the geochemistry, we can see older magma that got carried with a newer batch of magma and then erupted at the surface. You can actually sometimes see textural differences, or there's changes in the crystals in terms of how they're zoned. There's like little layers around some of the crystals that you can look at there. Quick little drink here. Hopefully this is good. I have no idea what's going on in the live chat. I have no idea how many people are on, but I see the live chat moving, and I see little blue lines, which is our moderators doing a lot of good work. So otherwise it's me staring at my computer screen talking. I want to look real quick at the live cam, if that's okay, just to see, because I know the sun was kind of setting. Oh, there we go. Yeah, let me just take a little quick pause from the... So now as we're heading toward these twilight hours, you're probably not likely to see that initial gas emission that will precede the eruption if we have an eruption. So it'll be much more obvious at this point as we go into the evening hours. If we have an eruption, which doesn't appear to be likely right now based on the seismic signal, what we would expect then is to see lava erupting out of the ground, and it'll be a big, bright orange glow. Pretty obvious. So, but we'll just have to see going forward. Yeah, these volcanoes can be, they're big teasers, I tell you. They just, you think they're going to erupt and then they don't. When you don't think they're going to erupt, sometimes they do. But that's what makes it kind of exciting as scientists, learning from those events. What did this, how much magma was moved in this event today that's taking place right now? What was the actual volume of magma that was carried by this event? Interesting stuff to think about for sure. So, yeah, I mean, it can be, I wouldn't call it, oops, I got too many windows open here. Frustrating by any means, but here we go. But it can be, like you want to maybe see what's happening and see some sort of event, and then nothing much happens there. So, who knows? Okay, let's get back to the questions here. Okay, where are we at? Here we go. All right, questions from, let's see, Benjamin, I did your question. Sue Nethercott, if this is an intrusion without an eruption, what pattern will we all look for before the next eruption? Continued possible GPS ground deformation. So, if this event kind of stalls and dies out, and essentially what this could be, even though we kind of got our hopes up for those of us that like watching eruptions, some magma leaked out of the reservoir, moved into that system, that big dike system to the east, but did not propagate up to the surface. And it's an intrusion at that point and not an extrusion, which is an eruption. So the pattern before the next one, we'd kind of look for the same sort of thing. We'd look for possible reinflation. If we just move some of the magma from the reservoir off to the east into this area north of Hagafeld, then presumably there might be a little bit more space for magma to come up into the system because you moved magma from one place to the next. So you might be able to accommodate some magma, but maybe not much. And if the magma can continue to find and occupy, as I said before, new spaces and pathways in the subsurface, then it will. And we will see earthquakes that go along with that as the earthquakes break the rock. So I think continued monitoring of the GPS data to see, do we have more elasticity at some of these GPS stations? Is there still elastic movement of the crust as more magma rises from below? Otherwise, I think that's what I would look for, is just continuing to monitor this behavior. And what we're looking for before the next eruption, just like we are now, is we're looking for those earthquakes to get shallower and clustered. And it might be only a few earthquakes. If it's coming up through a pathway that's been established, then it might be very rapid, like the Met Office has been saying, like 20, 30 minutes. It might be more protracted over time, like we saw today. We're looking at a multi-hour seismic event that may not result in an eruption. And we saw that November 10th. And so we may be going to this cycle where it's, inflation and then possible deflation. It'll be interesting to see with the GPS data if this thing ends as it is now, which is a big if the GPS data trends down at all. I don't think we've had, based on what I'm seeing, I would guess very little magma has moved out of the reservoir and into this new area where we're seeing the earthquakes. I don't know what that volume is, but it seems to be, I would guess it's pretty small, but we'll see what the modeling results come up as. Okay, once loved treasures. We saw the models of potential lava flows from various points, but would it be better or worse to have the same lava volume spread out through multiple eruption sites rather than one main source? Probably it's a little easier to It depends, if we're talking about Grindavik, it depends which one of those scenarios, right? Obviously, we don't necessarily want the vent to open up very close to or slightly upslope of Grindavik. We'd really like to have that vent open up elsewhere, but if it's going to be along this lineament or this system here, we'd like it as far to the north as possible. So maybe it depends on where the vent is. If we had a vent open up north of Stora Stogafelt that pumped out a much larger volume of lava, that would be better for the town of Grindavik, because you have all this other space for the lava to flow to and accumulate, and you're much further away, and it would take it would take a lot more lava to actually get that lava down towards town there. So that's a really good question and an interesting one. The better or worse angle is kind of like, that's a bit subjective, I suppose. Zachary Strauss, is there any possibility that this magma is silica rich and granitic and will separate to a lower temperature and cool to a pegmatite? No, this is basaltic magma. This is silica poor magma. It's low in silica. The entire Reykjanes Peninsula is made out of essentially the same rock in terms of its chemistry. The rock type that you see can vary a little bit depending on how it erupted. Did it erupt lava flows? Was it a little bit explosive because it was interacting with water or glacial ice, and so it fragmented into little pieces? But either way, the composition chemically of all that material is the same. So no granitic rocks and no pegmatites on the Reykjanes Peninsula. From one creature. I've seen others show the quakes in a 3D view. They can rotate. Do you have that option? It was very clear last time how the quakes moved upward in channels. Um, I could maybe try to dig into that a bit on the fly. I saw in my email I got, let's see if I can find that. Um, so our good friend Bruce Garner did send me, let's see if I can make this work real quick on the fly. This is terrible, terrible live streaming, but he did send me a 3D view of the earthquakes, but this was from, yesterday, so he doesn't have this most recent swarm. Um, yeah, let's see. Oh, and then he's got a bunch of graphs. So I didn't have time. This came last night, and it was Friday night, and I was with my wife, and then we had some other things going on this morning. So I won't unpack that mentally right now, but I'll try to look at that and maybe get back to you. So yeah, I don't think, but we know that the raw data, which I know is not as easily visualized as a 3D view, we can see that they're not coming up to a large degree, right? That they're mainly these deeper 5-ish kilometer earthquakes. So if I get that up and running, maybe on the next little live stream or something, I will. From Matt Bax 31, if the tectonic plates of the Earth's surface are moving relative to each other, what is the fixed reference frame that GPS uses to measure movement up, down to the millimeter? That's a good question. You'd have to ask someone that's more familiar with like how those are set up. I don't know what reference frame they use. If it was a school day, I could run over to the next hallway and ask my colleague Jeff Cooper, who teaches our GPS and GIS classes. That would be a good question for him, but I don't know off the top of my head. I apologize. Astronomy, according to Tony, is it too soon to see anything on the GPS data? Well, we can go back, and in fact, we could check out the, oh, beautiful. Oh, I don't have it live. There we go. Now it's live. Beautiful sunset there in Iceland. Just deep breath. Soak it up. Awesome. Yeah, let's look at the GPS data. There is, if you scroll down further, there is 4-hour ones. I tend to always look at the 8-hour ones, but these ones work as well. And let's see. So here's Fartsengi with 4-hour updates. And so if we just look at the uplift data, bigger error bars here. It's a little messy. Hard to say. You have a little upward trend and then a downward trend, but again, bigger error bars. So let's see if here's one at Thorbjorn. And yeah, that one's just not showing it at all. So again, I think there's so little magma that moved in today's event that I would be really surprised if we saw a noticeable shift in the GPS data at any given station or at multiple stations, but we'll have to wait and see. What else is in here? Let me make these a little bigger. Anything else I think might be, yeah, so presumably this is reflecting, I don't know when the last data point came in, like on these 4-hour data plots, what, was that like noon, 4 p.m., 8 p.m.? I don't know what time those new data points come in. So yeah, I think that's probably a wait and see question. That's probably I think to answer your question, yes, I think it's a little too soon to see anything on the GPS data. Probably should have started with that. Nancy C. Can't a deep quake occur below areas above that had already been loosened along that intrusion line? Thanks. Can't a deep quake occur below areas? Sure, but at some point, especially in the Reykjanes, we get to a depth of around 8-ish kilometers or so where the rocks don't behave like a brittle entity. They don't break and create earthquakes. They are more ductile, and we actually call that zone the brittle ductile transition zone. And on some of the cool cross sections we've shown from some of the science papers, they've actually delineated that on their cross section, that rocks behave brittly near the surface. So that means when a stress is applied, they break. When rocks break, that generates seismic energy. But you can reach a depth, and the depth varies from place to place depending on the heat. But because here in the Reykjanes, we have hot rocks at depth. We have a geothermal power plant. We're looking at volcanoes in different places. So the rocks get hot enough that instead of breaking when stress is induced upon them, they actually bend and deform and flow a little bit, if you will, without breaking. And so we really just can't get, you literally can't generate those deeper quakes because the rocks aren't behaving the way you need them to behave to generate an earthquake. They're not behaving brittly, they're not breaking. The fun analogy I sometimes use with students is take a Snickers bar, put it in the freezer, take it out of the freezer, apply a force to it, just take that Snickers candy bar and try to break it. And of course you can break it and it snaps, right? That's brittle rocks, that's near surface rocks. Take another Snickers bar, put it in your pocket in the summertime, go run around for a few miles, then take it out of your pocket on a warm summer's day. And now as you induce the same stress on it, that candy bar flows and deforms without breaking. And you got a chocolatey mess on your hands, but the rock did not break, it did not snap. So hopefully that helps a little bit there. Tim Holmes, please post your Google Earth project so we can copy it to Earth ourselves. Yeah, there were some people off one of the last live streams that mentioned how I can do that. I'm backed up on emails here, team. I apologize. That's something I'd like to do. I certainly know how to take the KMZ files and like send them to someone, but in terms of just posting them, I haven't totally figured that out. But some people have sent me some emails and tips on how to do that. I just haven't dug into those because I'm a little swamped on the email side. So please know that I always do try. If your email is just, hey, here's something cool, then I do look at it, but I don't necessarily respond. If your email asks a question or something like that, I do try to respond, but it's getting increasingly more difficult. But I am trying to keep up. It's a bit of a fight. I've always been one of those people that likes my inbox to be very clean. Like there's a few things there that I know are still kind of going on, and otherwise I respond and shift things to folders. But these last few months, I'm losing the email fight is what I'm saying. But I'm trying really hard, and I'm still in the battle. So hopefully that helps a little bit. From K Wolf from the Live from Iceland feed, how are you? Have you seen the near real-time GPS? There's some interesting perturbations there. Yeah, if someone can get that to me through Amanda Joe, that would be great. I'd love to see that right now. I have never proclaimed to be an expert on knowing where to find all the data that exists there. So I know when I'm looking at the data, I'm probably not seeing everything. And I'd like to see as much as I can. So if you have some of that, that would be great. So, okay, let's see where we're at here. It looks like I got the questions. Do I want to do more? How are we doing? Let me go back to, let's just double check let's refresh our feed real quick here and make sure we're up to date. There's our views. Let's look at the earthquake data a little bit here. And let's just look at the last hour or so. Because the Met Office thing did say that it had quieted down. And that does sort of seem to be the case. You know, if you kind of ramp this up to several hours ago, and then you look at just the last hour or so. Looks like things have slowed down a little bit. So, yeah, we might have been all jazzed up and then things quieted down a little bit. Amanda Joe says, I have loads of questions. Yeah, let's do another round, Amanda Joe. So if you have another page, I'll take another sip of water and I will do another round of questions. And then we'll just kind of have to see where this goes. I think when all this happened early this morning and I was out at breakfast with friends, just looking at the data and the small dots on my phone, I thought, okay, yeah, this is happening. An eruption's going to begin any time now, a couple hours at the most. and then the eruption may die down quickly, possibly within 24 hours, and then I might be able to get to that Nick Zentner interview easily. But now with this sort of thing in limbo a little bit, I'm kind of perplexed about what to do next. So let's see. No, I did not get the second batch of email questions yet, Amanda Joe. I just have the ones from 11:02 my time, from about 40 minutes ago. If you could send the other batch through, that would be great. And then let me also check. Here, I'll give you guys, put you back on this view for a second. And I'm sure, like me, you're probably sitting there, participating in this live stream, but also juggling a few other things as well. Let's see. I've got a couple other things that have come through via email. So let me see. Oh, there's an updated hazard map. So we could look at that real quick. That might be fun while we're waiting for those questions. And this came from Janet Naher Snowden. So thanks for sending that, Janet. It looks like it's trying to, yeah, last updated at, let's pull this over here real quick. And last updated on March 2nd at 6:15. So 6:15 Iceland time would be, 10:15 here. So maybe about an hour ago. So here's some of the, make that a little bit bigger so you guys can see it. Or not. Why didn't that? There we go. Oh, I got the emails now, Amanda Joe. Thanks. I don't know why they took a minute to come through. So seismic activity decreased. It is uncertain what the continuation of the activity will be. I think, there you go. There's the honest truth right there. What's going to happen next? All the inquiring minds want to know. We have no idea. Maybe the magma has moved as much as it's going to migrate, and that's it. The March 2nd event was a non-eruptive event. One of the scenarios that's been mentioned is that there's a magma flow without an eruption. And the magma flow term, whether that's a translation issue or not, that's the same as what I'm calling in American English an intrusion. Basically, magma has moved and intruded into the subsurface somewhere, but without an eruption. So they say seismic activities decreased, uncertain what the continuation will be. Quake started at 3:55, so that would be local time. So that was about 4 o'clock. So it was like, yeah, 9 a.m. here. That seems about right based on when I started hearing from folks. At the southern end of the fissure, which erupted on December 18th, seismic activity moved southeast along the magma corridor and stopped at Hagafeld. So that's pretty interesting there. So if we get rid of, let's take out the February eruption, because they said there, let me make sure I get the phrasing right, what they were saying, that it started the southern end of the December 18th fissure, and then it stopped at Hagafeld. So probably just for my purposes. So it started somewhere in here, just east of Selingerfeld, and then it moved this way. I don't think it was moving exactly along this trend. It seemed like maybe it was moving more in a southwesterly direction. So it's quite possible that we had magma move into the system and then inject into some fractures that were running southwest northeast in this area. And maybe that magma, based on the earthquakes, progressed as far as the base of this hill. Remember, there's so much we don't know, and there's so much variability, and I've talked at length about this, and I think I'm going to continue to talk about this because I think this is something that gets overlooked and maybe is one of the more fundamentally important questions or topics or themes, and that is to use the fancy word, the permeability architecture, or in other words, what are the pathways, what are the rock types, the fracture systems, the fracture connectivity, and the pathways in the subsurface down to about 5 kilometers. And we just don't know exactly. What role do these big, what we call table mountains or tuyas, these subglacial volcanic features that form these hills, their permeability and pathways are different than other ones. So we'll have to see. Amanda Joe says to check the earthquake website. All right, what am I looking for here? Has there been other quakes? Did I miss something? Maybe let me know what I'm looking for here. Looks like last 30 minutes, no earthquakes for the most part. Last hour, just a few. Yeah, a few quakes have come in is what she's saying. Okay, yeah, I agree, totally. Yep, thanks for that. Let's see. Okay, back to the Met Office update. Deformation is currently being measured as much smaller. Yeah, so it kind of just goes back to what we were talking about there, that it could just end without anything. And then I guess we have seen this hazard map, right? They're just putting these two zones in purple. Amanda Joe says there are some quakes coming in, but the site's a little lazy in updating, and that may be, there could be a little bit of lag time there, possibly. Let's see. Let's go to, there's our live view. Let me go back to, sorry for some of the delays here. I'm just trying to give you any information I can find. Yeah, a couple of nice well-wishing emails. Thanks, folks. And let's see if there's anything in this folder. Nope. Okay, let's get to that second batch of questions then and do at least one more round. There's actually 3. So if I do not get to your questions, I apologize. But let's get to this second batch here from Amanda Joe. Thank you, and thank you to Susan and Lisa who are doing some of the moderating there. What am I doing here? Here we go. So Amanda Joe's just also sending me with these question batches. It looks like just some of the updates she's seeing on the various news feeds and other possibly social media platforms. Magma does not reach the surface in the majority of cases. That's true. So every time we see magma moving in the subsurface, most of the time it doesn't make it. It's a hard fight for that magma to get its way, propagate to the surface, to fight through those fractures, to widen those fractures out, to have enough pressure and gas buoyancy that it can make its way to the surface. So the magma can move without reaching the surface. The majority of cases, when it does move, it does not reach the surface. This sequence of events, therefore, does not surprise Professor Thordarson. However, whether this event is over now and we have to wait for the new magma run for a few weeks remains to be seen. Absolutely. Agreed. May take several days to reach sufficient pressure. Professor Thordarson says that it seems that there's been some displacement of the magma, meaning it moved, it traveled some distance, which has lowered the internal pressure in the magma chamber. It may take a few days to build up enough pressure again for something to happen. Yeah, absolutely. Being volcanologists or being watchers of the volcano, as we all are, one thing we're going to learn here is patience, because the volcano is on no timeline whatsoever. It doesn't care that it's a Saturday. It doesn't care that it's daytime and a good time for an eruption for me. The magma is just going to do what it does. So Lizard Breath, Lizard Breath, do we know if Roger has posted the videos of the previous earthquakes that he put together? I haven't seen that yet. So if he sends me something, I will share that with you. But otherwise, haven't seen that. From Charles W53, is the Z movement data available readily so a trend can be generated without the error bars? There is a way to access that data more directly, and Bruce or some of these other folks that have manipulated the data would know how to do that better than I do. But you should be able to either contact them at office, or it might be there in the trenches somewhere. In fact, if one of those folks is on the live chat and wants to put a little brief summary of how they do that, that would be great. So Garden Birdwatcher, as the tectonic plates are so close to this area, why is the line where the plates connect not the weakest spot for an eruption? Okay, so the big misnomer, or I don't know if the misnomer is the right word, but the reality is that the tectonic plates, we have two plates there, the North American and the Eurasian plate. The plate boundary is not a single line. So even though on maps we draw a line cutting across the Reykjanes Peninsula, it's a bit of a disservice. So the boundary sits in here, but the boundary is actually a zone. And some of the tourism in Iceland doesn't help the cause either, because there's a place over here called Sandvik that you can go and allegedly go out to this bridge. And if you go out to the bridge, it says the bridge between two continents, right? So if you actually go out to this bridge, all the signs will tell you as the tourist that you are literally standing right here. This bridge separates one plate from another. So this is, this sign over here says, hey, you're on the, this I guess would be the, yeah, this would be the eastern side. North is that, this is the western. So this is, one of them's the North American plate, and then you walk across the bridge and there's another sign that says, welcome to the Eurasian plate. That's not true. Like, this is just one fracture zone. You can see there's others, right? Why is this little valley, this little crack in the ground, why is it any better? Let me switch north around so it's properly oriented. How is it any better than this one? Or what about that one? Or what about this one over here? These are non-eruptive fissures. These cracks in the ground in this part of the peninsula did not erupt volcanoes. They're tectonic faults and fractures. You see the same thing up at Thingvellir at the national park, where there's places where you can swim between the plates and snorkel between the plates. But if you get in here, you'll see it's a series of fractures. It's an entire valley. It's a bigger, wider system than one discrete line. And so, circling back to your question, as the tectonic is so close, why is the line? Yeah, so there's several. There's more than one fracture system. We have lots of fractures that mostly trend northeast southwest. I think in one video I showed you a paper where they'd mapped out all the fractures and faults in an area of the Reykjanes Peninsula, and there were like literally hundreds. And so any one of those fractures, faults, systems can be places that the magma utilizes. Also, recognize that a fracture you see at the surface doesn't necessarily extend down to 5 kilometers. And I almost want to, if I had the time, I would sketch out a cartoon that might show a possible magma pathway. The magma might find a fracture to come up, but then it runs into a hard layer, but there's a break between those layers. So now the magma is moving horizontally sideways, and then it encounters another vertical fracture that's a good pathway. So it moves up through that, and then it hits another dense layer above that's unfractured, low permeability. And so it moves horizontally between those layers. And then, so it's more this zigzaggy path that might be the true type of path that it takes. And so these tectonic plates aren't clearly designated by a line that cuts down to deep levels that the magma can then exploit. So hopefully that helps clarify a little bit. So astronomy, according to Tony H., can you give us an explanation of how the DAS measurement system works? I've not done a deep dive on that. That's the digital absorption spectroscopy. I think that's the one for volcanic gases, if I'm remembering correctly. And shoot, is that what it is? I think that takes you have to have a clear line of sight, and then it measures with spectroscopy the gas concentrations in that as the light passes through it. I obviously don't know exactly how it works, so I guess I'll punt on that one. But I've read a little bit about it. I'm just not a good expert there. Let's see, Amanda Joe just sent me something. So they're going to do another update, or they already did an update? Is that what it says, Amanda Joe? Let's see. Oh, now I lost your... All right, I'll just keep... So is there a new one? Okay, there's a new one here. So let me grab that real quick before I go to this next question. Again, this is all on the fly team. The moderators and I are just trying to figure this out as best we can. We'll go a little bit longer here and then maybe we'll shut this live stream down and maybe start another one either later today or another time. Looks like there's a new update out, so we could go in and maybe refresh this, or just go back and see. Is that maybe I need to go to the Iceland one? Is that a better way to do it? Okay, evidence that the magma flow is stopped at 1845. Okay, I think this is the latest one. Yeah, so this is the one Amanda Jo was keying me in on. Let's go ahead, make that a little bit bigger, and let's just digest this together, folks. Evidence that the magma flow is stopped. Too early to say that there won't be an eruption this time. At this point, the microseismic activity that started just before 4 o'clock today is stopped. It's likely that the magma flow, or the intrusion, has stopped for the time being. Deformation continues to be measured in the area. It's therefore too early to say that the magma flow or the intrusion is over and that there will be no eruption this time. In the case of magma flow, again, I would prefer intrusion, but that's what the term they use. Deformation is measured for several hours after the seismic activity stops. The Met Office, therefore, continues to monitor the area to monitor the activity, see if it'll pick up in the next few hours or whether it's over. There's a possibility that magma creeps up to the surface, as is the case with volcanic eruptions at Fagradalsfjall. So, yeah, so it looks like the earthquakes have stopped. And the earthquake stopping is a clear sign that the magma is not pushing into new areas. It's not propagating and widening fractures. So with that earthquake activity dropping, that's what we can say for sure. And we just have to see, did the movement of the magma relieve enough pressure that it's now stabilized for a bit, or will it pick back up again as more magma continues to rise from below? So, okay, let's do a couple more questions. Let me pull this up here. And let's see, I've got one viewer. Let's see. Yeah, Johan's up, and he went back to northern Iceland, and he sent me a message that, come on, Reykjanes, wait for me. Give me a week of R&R by Lake Mývatn. And then, yeah, so he's a little dismayed with the timing. So, okay, let's go back to those questions. And let's see, Rudy, we're at, yeah, Rudy Harderwick. How do they establish the magma flow rate below the surface? It's based on the modeling using mainly those GPS measurements. So I think when you mean magma flow rate, are you looking at the volume or the rate at which it moves through the subsurface? In either case, it's based on mostly GPS data, and then you can model that and see if your modeling matches it, right? So you can try different flow rates and see if that matches the amount of uplift and deformation of the ground. Obviously, there's assumptions built into every model, but I believe that's the way they do that without knowing all the ins and outs there. Okay. This is probably outdated because it's almost getting dark now, but from Tang Nosti, thanks, great updates, appreciate that. If you look at this camera, the valley appears to be filling with mist against the sunset. Is that steam or gases? It's probably the temperature dropping because the sun is going down, and so therefore the heat that is in that cooling lava field is causing the steam to be much more visible as it condenses. That would be my guess. Not gases, although it is probably degassing a little bit. At this point, it's mainly a lot of water vapor. Marin Angeli, is this sequence of multiple fissure eruptions in the peninsula similar to what we might expect from craters of the moon when it becomes active again? Yeah, I mean, broadly, the behavior is very similar. It's extension related. So even though craters of the moon in southern Idaho is not a plate boundary, it still is a region of extensional stress. The rocks are being stretched and pulled apart. And so we do expect that one possible eruptive behavior or characteristic at craters of the moon would be these fractures opening up as fissures erupting as fissures. Although we also see at craters of the moon, much more so than on the Reykjanes. The Reykjanes, you do see a few, there are a few shield volcanoes, there are some cinder cones, but I think the fissures, just as I look at it, that my notion would be that they're probably the dominant eruptive vent, at least in the last period of eruptions. At craters of the moon, I think fissures and cinder cones are probably sort of tied for the most common type of eruptive vent. Okay, no longer listless. For intrusion to turn into eruption, what would a lucky break or last straw? If the energy is not already dissipated, maybe magma finding a backdoor to Eldvarp out west. I think that's less likely. I think there's clearly preferential pathways and higher porosity and permeability in the system to erupt out here to the east. And so I just don't see any, I mean, the scenario for it erupting over here, we're not there yet. There's just no evidence, both in ground deformation and especially in earthquake activity, that the magma is going to migrate and come through this system out here to the west. Could it do that? Sure, that's like totally on the table, but I think we'd have plenty of precursor activity and warning signs leading up to that event. So, yeah. Can we see plate movement? Can we see plate movement across the craton? Or is the motion inchworm style? So you're talking about like continental cratons? Yeah, plate movement is average. So when we say a plate moves 5 centimeters a year, that's averaged out. Usually it's more episodic. So a lot of these fault systems work in sort of fits and starts over time. So stress builds and builds and builds until finally it fails. Things shift and move, that generates an earthquake. Then you reset the clock, the stress builds and builds and builds, and so over time it is, I guess, a little more inchworm style. So I think that's generally the more dominant type of movement that you refer to there. There are places though where we see what's called aseismic creep, which means you're getting low to no earthquake activity, but there does seem to be slow, very steady movement of the crust in that area. And they see that, I think they see that in parts of the San Andreas system in places. Yeah, I know that's been studied a little bit, but I think this is the more dominant type of motion, is this inchworm style as you describe it. So, Scotty does, let's see, Amanda Joe's asking me questions. Let me finish Scotty's question first. Does molten magma melt previously solidified magma, or does it travel a new path of least resistance? So remember that it's a spectrum from completely solidified magma that's basically hot rock to molten magma. And in between, there's these things we sometimes call it crystal mushes, where it has crystals, but there is some molten material as well. You can melt previously solidified magma, but usually it doesn't completely melt. It depends on relative temperatures. It's a heat exchange thing. It also depends a little bit on volume and surface area exposure. But can this fresh batch of magma inject into fractures that have older magma that's either completely solidified or partially solidified? Can it actually start to melt that a little bit? It can. But sometimes that doesn't, if that solidified magma is there, that pathway is blocked, and sometimes it's easier for that magma to find newer pathways through other fracture systems, rocks that have more permeability and pathways for it to flow. There's just so many variables there. So good stuff, team. Go a little further. I probably can't get to the third batch of questions. Let's finish this second batch. Then let's see what question Amanda Joe had, maybe wrap up a few things, and then we'll probably sign off here in a bit. So, but I do appreciate you jumping on with me. And I think we've been going now for maybe an hour and a half or so. Not bad. Artanis, is there a reason why the GPS data didn't drop or lift on the latest point. Oh boy, so I don't know which station you were referring to there. We don't know. I also don't know when that data gets refreshed. So as we look at this and maybe refresh it, and if we go to the 4-hour series or the 8-hour one, kind of doesn't matter a ton. Am I in the 4? Oh, I'm in the 8-hour one still. Okay, now we're in the 4-hour stream. Yeah, so why am I having trouble finding this one? Let's go ahead and refresh, start over. Start at the top. Yeah, so I think, let's see, 8-hour, 8-hour, 8-hour. Now there's 4-hour ones, but that's not. I was going to try to pull up the Svart Singi one again. But we could pull up Eldvorp, it doesn't matter. Quick refresh of the question. What reason why the GPS data didn't drop or lift on the latest point? I think we're probably not seeing, we may not see any movement in the GPS stations because we had such a small amount of magma move through the system, inject itself into fractures at depth, not fractures that were coming up to the surface. And because these fractures may have already had some, if you take a fracture that's maybe a little bit open, a few centimeters, whatever, and you inject magma into it, you wouldn't expect, therefore, there to be any up-down motion. You might get some east-west or north-south motion, especially if you've widened that fracture system out a little bit, but we may not see any movement in the up-down component at GPS stations because there just wasn't enough magma move through the system, and the magma that was moved through the system stayed at depth. That's my sort of on-the-fly response to that. So hopefully that makes sense. Great questions here, team. You guys brought your A game on a Saturday. Appreciate it. From Thulea Mayeni, can rapid extraction of groundwater result in seismic triggering, particularly if large aquifers contribute to regional overall stability? Really good, deep question. I spent 2 years working in the groundwater industry, not dealing a lot with seismic triggering, though. But it is true that in a large aquifer system, if you withdraw the groundwater quickly, and we see this in places like Florida where there's like sinkholes in the limestone, the cave systems in the limestone are occupied by water, and the water provides some level of pressure to keep the cave and the ground above it stable. And then when that groundwater is pumped out, maybe because we have a food processing plant or whatever the use may be for that groundwater, when the groundwater is depleted from the aquifer and the water table drops substantially, that's oftentimes a trigger for instability and collapse. Your question is more about triggering earthquakes. I'm going to say yes, that rapid movement of groundwater, whether it's being extracted or injected, can affect earthquakes to some degree. That being said, the earthquakes would be generally pretty small. And to some degree, this is like, and I don't have a lot of expertise on this, but this is, if we just change the word groundwater to more viscous liquids, materials like oil and gas, so pumping oil and gas out of the ground, that's been shown to affect the seismicity of a region. If you look at like Oklahoma, parts of Texas, also injection of groundwater. I think there was a case in the 80s, I think it was in Colorado, where they were injecting wastewater or something into the ground, and that actually caused earthquakes. They were small earthquakes, but it actually increased earthquake activity in that area. So really good question there. Oh, there's more than I thought. I thought it was at the end. Okay, well, 5 more. So Matt Bax 31, how are the locations of seismic activity determined? Some kind of time differential of arrival for multiple sensors, I guess. What kind of accurate can be expected? Solid question. So the locations of seismic activity, essentially, I think this person's asking, how do we know the earthquake's location is where we say it is? Um, I'll explain this, but I think maybe in some future video I'll do a more complete overview with some graphics, which I think will be helpful. So essentially what we do is we take the arrival times of earthquakes and look at them from different places. So let's say one location measures an earthquake, and the first waves that arrive in are the P waves, then there's a little bit of time, and then the S waves, which are stronger, and then finally the surface waves. Earthquakes generate three types of seismic waves, discrete sets of waves. Well, the P waves and the S waves move at known speeds through rocks of a certain type. And so if you measure the lag time between the P and the S waves, that tells you how far you are away, your location is, from where the earthquake actually took place. The P waves and S waves, if they have a short interval, the earthquake is very close to where you are. If it's a longer interval, then the earthquake's further away. And this can all be quantified. You can get numbers to this. So basically what I'm saying is if you measure an earthquake and look at the arrival times of the P and the S waves, you can determine where the earthquake was with respect to where you are. So that would give you on a map a circle around your location, right? You with me still? And then if we do that for two other places, they would also draw a circle around their location. And ideally, when all those three circles are plotted, they overlap or intersect at a common point. And so that is the location of the earthquake in terms of its epicenter at the surface. Now that can be done on a map. It's just called triangulation. It's no different than what your phone does with GPS and locating you and letting you know where you are. But if you think about it in two dimensions as circles, it's not really actually a circle. It's actually a sphere. So when you measure your location, and let's say we know that the earthquake was 5 kilometers from your location, and you draw a circle with a radius of 5 kilometers on your map, well, it's really a sphere with a radius of 5 kilometers from your location. So not only can we determine where the earthquake occurred on a map, but we can actually determine its depth as well. So that gives us three-dimensional data. That's like the 3-minute answer to something that probably takes a bit more time to explain well with better graphics. Hopefully that was helpful. Luen Lark, why are magma movement, earthquakes, and tectonic plate movement ones so similar that it doesn't seem any different? Good question. That's one of the trickiest things, especially for places like Iceland, where we know we have there's magma-driven earthquakes and there's tectonic-driven earthquakes. And they're hard to differentiate when we just see that there's an earthquake. Sometimes if we have the GPS data, that's suggestive. Sometimes if we have other data that can help, then we might be able to know one way versus another. It's difficult. In my interview with Professor Thordarson, we talked about that. And I think he said, you tell me, when I asked him that very same question. From Care Fraser, the other day you had possibly of where it might erupt at, let's see, the other day you had possibly of where it might erupt at, is any of them more of a possibility than the other now? I think in terms of location, if that's what you're asking, I mean, given where we saw the earthquake swarm today, that I would say that still falls into the realm of where we expect this next eruption, anywhere from the Hagafelt area up to Stora Stogafelt. This zone in here, if we just drew a big oval right here, I think that's the priority area, and that's the most likely place for an eruption based on what we're seeing so far. From Thulea Mayeni, is it practicable to dump man-made waste at subduction zones to reduce the methane and real estate footprint of landfill sites? Oh boy, that's a lot to unpack. In terms of practicality, I don't know much about that. Man-made waste, are we talking about like trash? Are we talking about radioactive waste? Are we talking about wastewater? Oh boy. I think we were saying though, like, let's dump all of our civilization's trash and problems and things we don't want to have to deal with at the surface. Can we just inject those into subduction zones? I think that has a lot of complications. You'd have to transport all this material out to these subduction zones. Subduction zones have very deep trenches, So getting them to the very bottom of the ocean, um, is that even deeper maybe than we can actually go? I don't know. I'd have to check on that. Then you'd have to get it down into the subsurface below that. I think that's just a huge matzo ball that is crazy to think about right now. Same person, is majority of regional faults are list. You mean listric? Listric, like curved in nature? Does this support seismic triggering? Not sure I get that question either. If the majority of regional faults are listric in nature, does this support seismic triggering? Maybe what you're talking about, this is kind of a deeper dive. If you don't understand that, that's okay. But some faults, instead of being planar surfaces, are actually curved. So they're shallower at depth. And then as they arrive towards the surface, they curve and become steeper. That's what we call a listric fault. And in some fault systems, there's a large listric fault, and then there's either what we call synthetic faults that actually kind of splay off of that, or faults that come into it from a different angle that are called antithetic faults. In terms of how that relates to seismic triggering, I just don't know. So that's a good question. Yeah, you asked some really deep ones there. You're doing some deep thinking there, and I appreciate that. I probably didn't do the best job answering those. So, okay, team. So it is in Iceland. What's great about sunset and sunrise is they take a long time. You're so far north that when the sun goes down, it doesn't just track below the horizon. It just kind of like drifts, along the horizon for a long period of time. So you can see it's still a little bit light there, but we can also see, if we come back to our earthquake data and just look at maybe the last 2 hours and give it a quick little refresh. Let's see here, 2 hours worth of data. Yeah, not much happening there. And if we look at the last hour or so, yeah, like it's gone silent, right? Versus 6 hours ago, things were happening. So we'll have to see how that all plays out. So anyway, real quick, let me check a couple things off my phone. I think I need a break from the questions. Hope that's okay. Oh, let me do Amanda Joe's question because she deserves it. She's asking, let's see. Still curious about this, LOL. Okay, she got my brain thinking, now I'm wondering about things. I've concluded that magma is lazy because it always looks for the path of least resistance to the surface. Well, saying it's lazy is personifying it a bit. But yeah, I know what you're saying. Yeah, like it, and I use that word all the time too with students, so it's okay. Yeah, but it's looking for path of least resistance. It's a viscous liquid under pressure from gases. It has buoyancy, and so it's trying to find the easiest path. Not necessarily to the surface. It's just trying to find the easiest pathway, which might be, like we saw today, like going laterally or injecting into some fracture. Continuing with Amanda Joe's very long message to me, but let's see what she's thinking. This is good stuff. In Svartsengi, we've had multiple eruptions now, and with the magma run, or as it's better called, magma intrusion, on the 10th of November, we've seen the ground open or loosen up quite a bit. Now we know that there's some kind of magma chamber under Svartsengi. Yeah, whether we call it a chamber or a sill or reservoir, there's some larger body of collected magma there, sure. By all accounts, it is a sill sitting 4 to 5 kilometers down with the rock above it too strong for it to tunnel up and break through where it sits. That's true. Hence the pathways made to the east and eruptions taking place there. Nice summary, Amanda Joe. This is great. You haven't even got to your question yet, but I'm like, you've laid out your train of thought very nicely. With all of these open pathways and magma being lazy, is it possible that we could start seeing a longer time between magma runs and eruptive episodes? So there's her question, but she continues on. I know that pressure and volume dictate the movement of the magma from the sill, but at the same time, I wonder if the magma leaks from the sill to sit in these already formed pathways, giving the need for more magma to be injected in order to reach the pressure needed for an eruptive event, thus lengthening the time between events given the current rate of injection. Or does the magma confine itself in the sill until the volume and pressure are reached and only then begins to leave and make its way to the surface? Well, just great job laying it out there, Amanda Joe. That's really some deep thinking there. let me read that last part again. Or does the magma confine itself in the sill? No, I think, and Professor Thordarson talked about it as like a lid, like maybe, there's uplift, the magma's pressurizing in the sill, whatever we want to call it, and then when the pressure is sufficient, then that allows some of this magma to then leak out of the system and inject off to the east, possibly forming an eruption, possibly, as in the case so far today, maybe not. Um, Yeah, so let me get back to your first question. With all these open pathways, is it possible we could start seeing, yeah, possibly longer time between magma runs, eruptive events? I think the thing that always changes too is with the earthquake activity today, right? Like even though those earthquakes were triggered, we think mainly by magma migration and breaking rock and filling in space, um, maybe that changed pathways a little bit. What if some fractures are enhanced now and wider? What if one fracture that was sitting here and another that was here that weren't connected? What if the earthquake activity today created a fracture that now connects them? And so the plumbing system is constantly changing. The way I see this, the regional earthquakes over at Lake Klevervaten, like those, all the things happening in this region, I feel like it's to a large degree the same, right? We've got the magma body, we've got the intrusion over here to the east, but in the details, I think there's a lot of changes taking place, and that's some of the variable factors that's determining where this goes. So I maybe don't have a great answer for you. I think your line of thinking makes complete sense to me. Um, so yeah, with all these, maybe now there's like multiple pathways. We've fractured the rock. November 10th just saw a lot of rock get open with all that earthquake activity. We've had 3 eruptive events since then. And so maybe now the magma is just, instead of building up that pressure to create an eruption, maybe now we see a period of intrusions where it's able to inject itself into these pathways. Um, and like Amanda Joe said, it's going to take longer to get to an eruptive event. We just don't know. I think, by the end of 2024 and whatever we see over this next, 6, 7, 8, 9 months, that will give us a lot more information about how this system seems to be working, and maybe some more information about how that plumbing system looks and how it's put together. So hopefully that was helpful. That was a really, really good question there. Hopefully I did an okay job answering that. Let me pull up one other thing here. Okay, take you guys back to the sunset view there in Iceland. And let's see. Just want to make sure I've got, let me just check a couple other things here and make sure there's nothing else coming in that, oh, and Amanda Joe said thank you. Great. Hopefully that was kind of helpful. So, good work here, team. We may not get an eruption, but the learning is happening, so that's good. Looks like that email is okay. Let's see. I did get one email from a viewer. Yeah, that's not what I'm really looking for. Let's see. Let's see. Okay, I think that's about it. So I wouldn't say much ado about nothing, because this thing could change potentially, and we've got thousands of people kind of watching this thing, whether you're here with me or on the webcams or whatnot. But we'll just kind of wait and see. But as for me, I'm not sure what I'm going to do next. I got some things to do here at the office. I'll kind of keep checking this. But if things continue, unless the seismicity picks back up, I can't imagine I'll jump on and do another live stream. For Nick's interview tomorrow, I think we should go for it unless something happens. Let's see what the viewers think. Should we, those of you that, I know a lot of people are really looking forward to my interview with Nick tomorrow, and I still need to do some prep work on that today. we did chat yesterday and put together some things. So does that sound like a good plan, team? I guess I'm sort of talking out loud and trying to convince myself that if unless the earthquakes pick back up and something looks like it's going to happen, I think we should go ahead and plan on the live stream interview with Nick Zentner tomorrow at 10 a.m. Mountain Standard Time or 5 p.m. Iceland time. And that's already posted on my YouTube channel, that event. So I think we stay the course. Does that sound good? Yeah, go for Nick. Go for it unless something happens. Looking at the live chat, yeah. Yeah, I think that's the right decision. That feels good. He's fine bowing out if something big happens, so it's great that he's flexible that way. We can always circle back to him if something big like this takes precedent. And so I think I'll just get prepped for him the rest of today. We have a little social thing this evening, and then I'll be back with you guys tomorrow for our interview with Nick. Now, one little caveat as we look forward to that interview with Nick, just so you know, we're not talking a lot of deep geology tomorrow. We're kind of doing a bigger picture on a little bit about Nick's sort of public outreach career, if you will. I want to start with that, even though he doesn't like talking about himself. We'll get him talking about himself a little bit and some of the things he's done. And then that'll segue a little bit into how he and I kind of first interconnected. And then I want to spend the bulk of the time talking about a bigger picture issue with like how the public accesses science and some of the barriers that science unfortunately puts out there, either intentionally or not intentionally, to the public, and how we might change that game moving forward. So that's the conversation I'm hoping to have. You guys are welcome to be on that live stream, and our moderators will aggregate your questions, and you can either ask Nick a question, you can ask me a question, or you can pose a question to both of us. So that's the game plan I have going forward. So yeah, I think that's good. Thanks for everyone that was participating here. I think we all got excited. I know a few hours ago I was like fairly sure that we were going to see lava on the ground in Iceland, and doesn't look like that's the case today. So, but it's interesting, right? Here's another interesting chapter in this story, and it's why I'm so captivated with this place among other reasons. So thanks again to Amanda Joe, thanks to Susan Helmer, and for Lisa R for being our moderators. I hope it wasn't too much work for you ladies to do that for me today, but I much appreciate it. Thanks to all who've contributed to the channel, helped make this possible. It is a bit of a labor of love, but obviously any support helps me put things together, get out and do some of the field work and the field videos, random road cuts, whatnot, and just continue to get motivated to do this. So I can see some of the names there: David Roberts, Deanna Porter, Futhela. I think you posed some of the questions. I probably missed a bunch of the others in the live chat, but I think the moderators do a good job of thanking you when you donate. So thanks so much. Enjoy the rest of your Saturday, or maybe it's already Sunday where you're located. And we'll get on with you tomorrow for our live stream with Nick, unless there's something big that shakes up and happens here soon in Iceland. It'll be interesting to see, one last thing as we sign off, it'll be interesting to see how the public officials handle Grindavik residents and the Blue Lagoon going forward. Because if these earthquakes don't ramp up again, when do you indicate and signal the all clear? Like how much time do you need? How much time is enough to say, well, it doesn't look like there's going to be an eruption. Let's let the residents back in. Let's let the tourists into the Blue Lagoon. And I certainly don't have an answer there. It's obviously a difficult decision to make, and you don't want to make the wrong one, and you'll clearly make people unhappy no matter what you decide. So it'll be interesting to see how that's handled. But I've always been impressed with the Icelandic people, their country, even their government. They're doing a lot of things right, and they may not be perfect, but I think they'll do the best they can, which is all anyone can expect. So thank you so much, team. Thanks for joining us. Appreciate you. Hope we had some good learning happen here as well. One last thing from Mandy Joe, who just sent me a quick message as I know I've like false started the conclusion here. Much less deformation in the past than in last eruptions. Benedict Olfigson says that the deformation of the magma tunnel was much smaller than the last eruptions, which means that there's less flow into the tunnel. It is possible that this event's coming to an end, but then it would be short until the next event. Kind of, I feel like that jives very well with everything I told you here today. So it's always good to hear from other scientists and folks, especially in Iceland, that agree with that. He says, however, it could happen that the magma creeps up in the next half day. If land rise continues, it must be assumed that it will be about a week before the next eruption, at least not a month. So yes, that does mean that even if we don't get an eruption now, that next eruption is still there in the future, but maybe not in the distant future, right? We're still expecting something possibly within a week or so. We'll just have to see. So, all right. Thank you again, friends. We're going to go ahead and shut this down. Thanks for being part of the live stream here today and learning with me. Appreciate the great community we've created here. Thanks again. I know I've said it several times, to the moderators for all they do. And I hope you have a great day. Keep watching the live cams if you want to, and just keep abreast of the seismic information. And I'll jump back on if anything happens, but otherwise we'll hopefully see many of you tomorrow for our live stream broadcast and interview with Nick Zentner. Thanks again. Take care and be well.